I'm going to use this time to explain Lab 3. We use Google Earth to better understand plate tectonics, and the data that we have to use in Google Earth is really powerful, really impressive. But in the past, some people have had trouble with files and using Google Earth, so I want to take this time to make sure I explain it as best as I can. And you know that you can always email me, or we can have some kind of video call or other meeting to better understand the lab. Anyway, so here's the page that you'll see. Two parts to this lab. The first is just a basic orientation to help you understand Google Earth. It might be very easy for you if you're familiar with it. Maybe you haven't had to use it before, so it's all new. The second part, these are files that you open with Google Earth, the Kmz files. So you download it, and assuming you have Google Earth on your computer, you will. You'll open these files with Google Earth, and I'll show how that works. Also in the lab, I have referenced these videos, so you're going to have to stay connected to the Canvas page, come back and watch the videos to answer a couple of the questions. And all that information is entered into this file. So we'll start off with the first part. Make sure you have Google Earth downloaded. I've linked you to that. We have a user's guide through Carleton College. Really useful stuff here. You may or may not need it, but I've linked it for you. I only want you to turn in 2 screenshots to me. You don't have to take a screenshot of your home or anything like that, but I want you to know how to find latitude and longitude within Google Earth. So just as an example, I'm in Nepal right now, but say I live here. Why not? Or I could say that this is my house, or I just want to drop a pin here, so give me a minute. All right. So if you want to have a place marker, here's a field. I can rename it here after clicking on the sort of thumbtack icon. And I see the latitude and the longitude for that point. If I want to move the point a little bit, I can do that. And in the bottom right, I see latitude, longitude. I have no idea why, but today my elevation data hasn't been working. But I do have eye altitude as well on the bottom right. That's just showing me like how many meters I am above the land surface. So if I move in, you can see that my eye altitude goes down. You should also see the land surface elevation, but for whatever reason, that's not working for me today. All right. So yeah, don't send me your house latitude, longitude, just know how to use it. Additionally, I did navigate to Nepal previously, so in the top left, type in Nepal. You're going to zoom in and out, of course. You'll know how to do that. What I want you to do is go there, zoom in and out until your eye altitude in the bottom right is about the height of Mount Everest. You're going to make sure that you're looking north. So let's go back to Nepal itself. Sure. My eye altitude right now is in kilometers, so that's the scale we're working with. Gotta go way down. All right, that'll do. And you can look to the north, of course, by clicking on the north arrow, and then use this to kind of look at the land surface and profile. All right. And there's a couple other things I ask you to do here, but all this results in you taking a screenshot of what you see, copy that, paste it, insert it into this document. You could also, to practice, create a place marker for some place you like, but you don't have to turn that into me. All right, the next thing you need to do for this assignment, show an elevation profile across Washington State. So, get out of that. So here we are in Washington State. This uses cross-section and elevation profile kind of interchangeably. These are elevation profiles. A cross-section would be like if you could actually see the rocks in profile cutting a slice through the earth. But regardless, I don't want that to confuse you too much. So what you need to do to make an elevation profile, click on this ruler tool. Click on the Path tab. And first off, you can make a few lines. We're just about in Montana there. And then within Path, hit Show Elevation Profile. Pretty interesting. You find when you have this elevation profile, as you run your mouse along it, you can see where you are on the map. You see that block arrow moves with you. So that'll just be useful to know for the main lab. Take a screenshot of this, paste it into the document, and turn that in for credit. Okay. We'll move on to the main thing here. So like I said, you need to download these Google Earth files. You can do it one at a time so as not to confuse yourself. So in my case, when I download it, you could save it, but you always want to make sure you open it with Google Earth. I have that by default because I use this so much. Okay? So here we go. There's a lot in this file. Right now, on the left-hand part of my screen, the file is located under my temporary places. And it's not checked. You have to check it in order to see it. Okay? And then with that, make sure the arrow points down. That way you continuously expand all of this data. It's all here. And it's all referenced in the lab. Okay? So right now I have everything showing up at once. Kind of overwhelming. We're showing with these rainbow stripes, we're seeing seafloor spreading and the age of the seafloor in million years. So these purple-blue colors moving away from the mid-ocean ridge are much older seafloor. This is new seafloor, right? If you are to zoom in, we have earthquake data. And again, the seafloor stuff, there's an axis there that shows you how many millions of years before present. These points are the earthquake data. You can see in orange that 0 to 33, that's the depth. So those are relatively shallow earthquakes that we have plotted all along the mid-ocean ridge. I can get rid of the age of the ocean floors by unchecking the box. I can move upwards. This is earthquake data. This was from that point in time, from the past 7 days, from the past 30 days, 2017 and 2016. There's just like a lot here. You can see that I kind of unchecked that, checked it again, and the scale for the ocean floor came back on top of it. If I want to get rid of this cool stuff here, the earthquake, I can start to uncheck these boxes. It just makes it easier to read stuff. But anyway, so the other thing that's in here, we have plate names. Those are all highlighted. If you want to isolate something, uncheck all the other boxes and only check the boxes next to the information that you want, right? Cross sections, these are important too, and they involve elevation profile. So like I said, they use cross section and elevation profile interchangeably. Let's start at the beginning. So yeah, we're in part 1. This is the elevation profile that is in the Google Earth file. We show it here. I'll show it to you in Google Earth. So let me get rid of this because it's a little distracting. Under cross sections, you have Atlantic. First off, let's fly there by double clicking on it. It's this thing, across the Atlantic. Yep, across the Atlantic. If you right click on it, you can hit show elevation profile. All right, and this is in your lab, but it helps to look at it here because what happens when you trace this, you can see your arrow on the Google Earth image. So you can see what the ups and downs in the profile correspond with. And like what we see here by Florida is a huge drop in elevation, which is also the continental shelf, kind of the edge of the continent itself, right? And then we go out into the middle of the Atlantic and the elevation goes up around the mid-ocean ridge. Okay, so this process is repeated several times in the lab, and that's how to access that information. If you want to go to like Sumatra, you double click on that real quick. You can do show elevation profile for that as well. Play around with it. So yeah, you see the screenshots in your lab, and then you can play with them in the file itself. Okay, so for part 2, the process is the same for this part 2 data set. We're going to download this and open it with Google Earth, of course. And I still have the part 1 file in here, but I have unchecked it. So I'm only displaying part 2 information right now. I can use all of this to answer the last questions. All right, so we have earthquake data and different faults. We can expand this. See tectonic plate boundaries. We have a number of things here. Continental collision boundaries, continental rift boundaries. See, those are color-coded if you look closely. You have a continental transform fault and a spreading rift, oceanic transform fault, and a subduction zone, and then earthquake data below it. All right, so with that, you need to answer these 2 questions. And just think about which type of plate boundaries. You can use the book too or other resources to answer what type of plate boundaries are associated with bigger earthquakes and more numerous earthquakes. And then just give me some explanation for this. Would you pick out either of our two regions and say whether or not they're seismically active based on, say, the last decade of earthquake information? All right. So, if you have any questions, let me know. But that should at least get you started with the files. And hopefully you work with the files early on in the week so you know if you have any trouble.